Let's go to 2D hydrodynamic modeling. Here we can really consider lateral flows as well in the X direction and in the Y direction. Normally you have two different grids, one grid for the river itself, more in a rectangular way, and a triangulation in the foreland or in the inundation areas. There might be an inundation now. You have really different velocity vectors here, X and Y, and for the river also, but mainly in the direction of the grids. That's very nice, and that's all. You don't have to consider anything. You have to consider the roughnesses, but the turbulent shear stresses are well reproduced here. So here's an example also from the upper mine again, and the pros are of course a good representation of flow in the floodplains and in the river. The accuracy is good, and you can also calculate, for instance, riparian forests and the retention of riparian forests in the floodplains. You cannot do it with a 1D model. So all these retention effects based on different roughnesses on the spatial variability in the floodplain is much better done by 2D models. The cons, yeah, you can imagine, it's of course a calculation time. It needs hours and hours to simulate a small stretch, still, if you don't have a very big mainframe computer. The setup is really similar. I can go quickly through this. The river mesh creation in the floodplains and in the river, you merge both meshes together, you implement building bridges and other constructions, you segment the river system with different roughnesses again, the calibration and the validation. So the same thing. So the setup is not more time efficient or time affordable than with a 1D model. But the computation time, that's a problem.